Multiplying and dividing radical expressions. When you're multiplying and dividing radical expressions, you're going to use the product and quotient properties of square roots that we've already learned in section 11.7. So we're going to be making some connections with what we've learned into this new section here of multiplying and dividing these radical expressions. So our first example, it says multiply. Write each product in simplest form. So the first thing you're going to look at is you have the square root of 5 times the square root of 10. And you're going to use the product property of square roots. So what you're going to do is you're going to multiply square root of 5 and square root of 10. So you take the square root of 5 times 10, which is going to give me, when we multiply this, under the radicand, it's going to give you the square root of 50. Once we multiply these to get the square root of 50, then you're going to factor 50 using a perfect square factor. So remember I talked about in class you're going to use at least one perfect square number. So what two numbers are factors of 50, one being a perfect square number? Well, that's going to be 25 and 2. So you take the square root of 25 times 2. And then we're going to use the product property of square roots, which is the square root of 25 times the square root of 2. So we broke it apart. What's the square root of 25? That is 5. So we're going to simplify this. Square root of 5, you cannot break down the square root of 2, so you just leave square root of 2. 5 times the square root of 2 is going to be your final answer. Looking at the next situation, we have parentheses 3 times the square root of 7 and parenthesis that is squared. So what we have to do is we need to expand the expression. So this is 3 times the square root of 7 squared. So we do 3 times square root of 7 times 3 times square root of 7. We just broke it apart, we squared it. Then we're going to work with the commutative property of multiplication. So what you're going to do now is you're going to multiply both of the 3's, and then you have like radicals with the square root of 7. Remember we talked about this previously as well. So then we're going to be working with the product property of square roots. So what you do now is you do 3 times 3, which is 9. Then you multiply the square root of 7. Square root of 7 times square root of 7. 7 times 7 is 9. So what you're going to, or 7 times 7, I'm sorry, is 49. So you're going to simplify the radicand. So what we're going to have now is 9 times the square root of 49. 49 is a perfect square number. Square root of 49 is 7. So when we simplify the square root, our final answer is going to be 9 times 7. And that'll simplify down to 63. Looking at C, we have the square root of 2m times square root of 14m. We're going to factor 14. We cannot factor the 2m, but we can factor the 14. So when we factor that out, we're going to think of a perfect square number, or actually not necessarily, we just are going to factor it out. So we have 2m, square root of 2m, times the square root of 2 times 7. 2 times 7 is 14. We're then going to work with the product property of square roots. So we have square root of 2m times the square root of 2m times the square root of 7. Notice I have like radicals of the square root of 2m. So we're going to take the square root. So we get square root of 2m squared times square root of 7. And then we're going to simplify this down. The square root of 2m squared just becomes 2m, because when something's squared, to unsquare it, you take the square root. So we end up with 2m times the square root of 7. Square root of 7 is not a perfect square number, so this would be your final answer, 2m times the square root of 7. So what we're doing is we're using all these different properties we've learned in this chapter, and we're pulling them all in for this section here with multiplying and dividing radical expressions. So just make sure you're following the steps when you're solving, and you might need to go back to these notes when you're solving the bookwork to remember all these different steps. The more you practice this, the better you'll get at it. So now we're going to multiply, and they want us to write each product in simplest form. Here we're going to be working with the distributive property a little bit. So we're first going to, for A, we have the square root of 6 times square root of 8 minus 3. So we're going to distribute the square root of 6 to each situation inside the parentheses right here. So when we distribute this, the square root of 6 times the square root of 8 is going to, we multiply that, minus the square root of 6 times 3. We're going to pull out that 3 in front of the square root sign, so minus 3 times the square root of 6. We're then going to multiply the factors in the first radicand. So what I mean by that is you're first going to multiply 6 times 8, and you'd leave the second set here the way it is. So what we're going to get is square root of 48 minus 3 times the square root of 6. So what we're now going to do is we're going to factor this square root of 48, and we need to choose a perfect square number when we factor this square root of 48 here. So when we factor it out, it's going to be 16 times 3 minus 3 times the square root of 6. 16 is my perfect square number. We're going to work with the product property of square roots. So we break apart the square root of 16 and the square root of 3. So what we have is square root of 16 times the square root of 3 minus 3 times the square root of 6. Now we're going to simplify this down. Square root of 16 is 4. So we're going to get 4 times the square root of 3 minus 3 times the square root of 6. And then that is going to be my final answer. You cannot combine any further because you do not have like terms under the radical sign. Looking at B, we have the square root of 7k times the square root of 7 minus 5. So here we're going to distribute 7k to each situation inside the parentheses. So what we do is we do 7, the square root of 7k times the square root of 7 to get square root of 7k times 7 minus, then we distribute square root of 7k times negative 5. So minus 5 times the square root of 7k. We're now going to use the product property of square roots. So we are going to multiply together 7 times 7k minus 5 times square root of 7k. 7 times 7k is going to give me 49. So what I'm going to have is, we're going to have the square root of 49k minus 5 times the square root of 7k. So the square root of 49k is going to be 7 times the square root of k minus 5 times the square root of 7k. So we simplify this down. Let me pull this up so it's a little neater. And so we get 7 times the square root of k minus 5 times 7k. And that'll be my final answer right here. We're now multiplying, we're working with FOILing method with multiplying these radical expressions. And in Chapter 7 you learned about multiplying binomials using the FOIL method. So we're going to do this now working with square root expressions that contain two terms. So here we have an example. We have the parenthesis 4 plus the square root of 3 and parenthesis times parenthesis 5 plus the square root of 3. So we're going to use FOIL. So we're first going to multiply 4 times 5, and we get 20. Then you're going to multiply the outers here. So 5 times the square root of 3. And you'll also do 4 times the square root of 3. So 4 times the square root of 3 plus 5 times the square root of 3 gives you 9 times the square root of 3. And then you multiply your last, the square root of 3 and the square root of 3. Square root of 3 times the square root of 3 gives you the square root of 9, which simplifies to 3. So now we combine like terms here. So we have 20 plus 9 times the square root of 3 plus 3. Add 20 and 3 to get 23, plus 9 times the square root of 3, and that will be your final answer. Honestly, when you're working with FOIL, with multiplying square root expressions, it's pretty simple. It's not too involved here. Let's do some examples of this. We have 3 plus the square root of 3 in one set of parentheses. Then in the second set of parentheses, 8 minus the square root of 3. So we have to use the FOIL method to help us solve this. So the first thing we need to do is we multiply the first 3 times 8, which gives me 24. Then you're going to multiply the outers, 3 times the square root of 3. So we have 3 times the square root of 3. Notice there's a negative in front there, so they did minus 3 times the square root of 3. Then you multiply your inners, 8 times the square root of 3. And then you multiply your last, square root of 3 times square root of 3, which gives you square root of 9, which breaks down into 3. Notice it's minus 3 because a positive and a negative becomes negative here. So you have 24 plus 8 times the square root of 3 minus 3 times the square root of 3 minus 3. And when we simplify that down, we simplify it by combining our like terms. So we do 24 minus 3, which gives me 21. 8 minus 3, we can combine these because they both have the square root of 3 here. 8 minus 3 gives me 5 times the square root of 3, and this is my final answer. 21 plus 5 times the square root of 3. Looking at B, we have in parentheses 4 minus the square root of 3. Second set of parentheses is square root of 3 plus 5. So what I'm going to do is FOIL. So we're going to multiply 4 times the square root of 3. Then we multiply 4 times 5. We then are going to multiply negative square root of 3 times positive square root of 3. And then negative square root of 3 times 5. So what that breaks down into is 4 times the square root of 3 minus 3 plus 20. How did I get this minus 3? Well, square root of 3 times the square root of 3 gives me square root of 9, which breaks down to 3. A positive and a negative gives me negative 3. 4 times 5 is 20. And then we multiplied this 5 times the square root of 3, which gives me 5 times negative square root of 3, which is negative 5 times the square root of 3. And then we simplify this down by combining like terms. So we have negative 3 plus 20 is 17. Then we have 4 plus negative 5 is negative 1. So that's how we got negative times the square root of 3. And this is our final answer, 17 minus the square root of 3.